Okay, so this one, you need to find the mean and the standard deviation. So the time taken to make a component may be modelled by the normal distribution. 10% of components take over 90 minutes and 20% take less than 70 minutes. So the way that's going to look on a normal distribution sketch. So 10% over 90 is my mean, and 20% less than 70. Quite sure how realistic that is, but not to worry. So that there has an area of 0.2, and this bit here has an area of 0.1. So we're basically going to get two simultaneous equations. If we start with the 90 minutes component, so again, we're just mapping with the standard normal curve. So consider Z normally distributed, mean 0, standard deviation of 1, and we want the probability of being to the left of Z to equal 0.9. So you need to remember that your calculator does to the left of a value. I'm sure you're getting the hang of that by now. And then, same as you've been doing, I don't think you need my calculator, I've decided now. Menu 7, inverse normal 0.9, dosh, dosh, and you get Z is equal to 1.281552. So I would just write that to 6 decimal places is fine. You can store to X. You can also store, if you didn't know, to A, B, C, D, E, F in red along here. So you can, I'm hoping it's going to work now, press store A if you want, and then that's stored to A. I'll calculate a tip for you. And then we're mapping back, so we're using Z equals X minus the mean over the standard deviation. That's basically how many standard deviations away am I from the mean on this distribution. So 1.281552 is equal to 90 minus the mean over the standard deviation. So if I times by the standard deviation, then that gives me 90 minus the mean, and that's my first equation. And then doing the same with the 70 minutes component. So some of you, I think your work could be laid out slightly better. So even if all you do is 70 minutes underline, it just makes your work so much clearer. So do try and present a readable argument, please, if you can, with your maths. Right, so we want the probability of being to the left of Z to equal 0.2. So I'm here now, and I want that to be 0.2. Because Z is going to be to the left of the mean, we're expecting Z to come out as being negative. So if Z is negative, you're over on the left-hand side of your distribution. And again, that's just inverse normal on the calculator, and that was my cat, or our cat even. So 0.2, and you get Z equals negative 0. We feed her, and then she just forgets where the food is. She does it every night. And then we have to open the door for her and close it about 1 million times. Right, negative 0.841621 for Z. And then same thing, so Z is equal to X minus the mean over the standard deviation. 0.841621 is equal to 70, which is my x value, minus the mean over standard deviation, times it by the standard deviation, that's equal to 70 minus the mean, and that is the second simultaneous equation. So now, top calculator tip, I can store that one to B. So I've got the second of those stored to B, and then we're solving these simultaneous equations. Sorry, it'd be helpful if you could see them both. Let's do that. Will that work? I think that'll work. So I now want to basically subtract them. I mean, you could put them into your calculator, just add the mean and then just read off the mean and the standard deviation. That's easier. Or you could do one minus the other. I feel like I should be encouraging you to use your calculators. So you can either do 1 minus 2, or if we essentially rearrange this one to make it 1.281552 plus the mean equals 90, negative 0.841621 plus the mean equals 70. I know I've been talking to a few of you about using your calculators for these. So menu A, or you can just scroll down. We want a simultaneous equation. There's two unknowns, and I'm pretty sure you can put your A's and B's into there. So to pull up A, I can do alpha A, and then that just pulls up that value. So hopefully you got that okay. Mean is 1. Lots of the mean doesn't equal 1, but the coefficient is 1, and that equals 90. And then to pull up this value, I can do alpha, which takes you to the red, so that takes me to B, and then 1 again for the mean, and that equals 70. And then you can just hit equals. So do feel free to do them like that actually if you want to. And so just reading off of there now, the standard deviation is equal to 9.42, and the mean, if I press equals again, is equal to 77.9. So you might want to just practice that a little bit on your calculator, possibly. But that's kind of putting that one there, that one there, and using the calculator. Or you can just do 1 minus the other if you want to. That's absolutely fine as well, because they're quite straightforward. You are expected to use your calculator quite a lot, so it's absolutely fine. Yeah, so if you could just do a few of those, they're no harder really, except you just get these two simultaneous equations at the end.